Let's see. So, what are we doing first, Bernie?
Okay, so we're going to look at three things today. One is the beginning of number. So we're talking about number sense with very young children, nursery reception. And then we're going to eventually do what you want to do is the simultaneous equations.
Oh, yes.
But in order to answer your questions on that, we're going to do negative numbers in the middle.
Got it. Okay.
So I'm going to start at the beginning of number, how this all comes about, number sense. So basically, children need to find how numbers are a couple of important things, how numbers are related to each other, and that numbers are made up of other numbers.
Okay.
And that's basically what we want to do. And as I was telling you, we were out in Uganda, we go every year, and everything that they do, they count in ones.
Right.
So if they were doing 9 plus 8,
yes,
they would write dashes 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah.
And underneath they would write 8 dashes 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
And then they would count all the dashes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
So they're not counting on, they're going back
No,
to
they're not even counting on.
Flipping heck.
So they were counting in ones.
Right.
And when I first started doing this about 6 years ago, I found a lot of primary children, if you asked them to do 7 plus 6, they were counting with their fingers and using their fingers to count in ones as well. And that isn't really developed number sense. They're only seeing numbers as clusters of ones.
Okay, I see.
Which is one of the things with dyscalculia, is that children only see them as clumps of ones. So we want to develop this counting with children so they get further than that.
Yes.
So there are lots of different equipment you can use. So the first thing is there's verbal counting.
Okay.
So children have to learn all the names, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And they eventually learn to separate those out. They get them in the right order. And we're starting with to 5 first of all, then to 10, then to 15, then to 20. But they also have to do what we call rational counting. So for example, if you ask a child, they might be able to say all the number names to 100. Right. But if you ask them to count how many objects are down here, they might do things like 1, 2, 3, 5, 7.
Oh, God.
And they've got to learn to say all the numbers in the right order.
Right.
They have got to learn to touch each one and give it the correct name. So you do 1, 2, 3, 4.
Yeah,
this is quite complex for young children to do this.
Yeah, I can imagine.
They've then also got to learn that about the cardinal property as well. So when you ask them how many there, they'll go 1, 2, 3, 4. Good. How many there? 1, 2, 3, 4. Right. Good. So how many are there? 1, 2, 3, 4. And they're not answering that question. So they're counting, but what they're not getting is when we say 4 here, this last one is not just the label of this, but it is the quantity. There are 4 things here.
Now, can I ask at this stage, Bernie? So I did a lot of reading for my book about this, and you see it on Twitter a lot, this distinction between biologically primary knowledge and biologically secondary knowledge, and the work of David Geary. And some of the reading I've read suggests that some elements of counting are biologically primary and some number sense seems to be innate, whereas a hell of a lot of maths is biologically secondary and therefore needs to be taught. What's your take on that? What do you think kids know naturally, and where does that stop?
I think that we're coming to that. There's another thing called Subitizing.
Oh yes, I've read about this. Yeah.
And young children, 6 months experiments will recognize quantities. Though if you put 2 dots or 2 things flashing up on a screen, after a while they disengage.
Okay.
But if you suddenly change that to 3, they'll come back because they're aware that there's a difference.
Yes.
So they begin to become aware in a spatial way, and this is primary, and animals can recognize whether there's 3 or 4 as well.
Yes.
Chickens will know which one to go behind. They'll know which one there's going to be more food behind they've seen.
Right, okay.
So there's some innate thing.
Yeah.
And unfortunately, if you'd asked teachers in primary schools 5 years ago, so Subitizing, no hands up at all.
Yeah.
And yet it underpins everything.
Absolutely.
So the drive these days is to start building into this Subitizing and spending time on this innate thing that we have within us and developing with that rather than just going straight to the formal maths that we're teaching.
I see, got it.
So the other thing is that we'll come to anyway, is when you look here, I put these in a 5 frame, they're structured.
Yeah.
So how many here, children are going to say 4?
Okay.
How do you know? Well, I can see 4, I can Subitize to 4, but I also know that if there were 1 more, that would be 5.
Yes.
So if you take 1 away and there's 1 less, I know that's 4 because there's a space missing here.
Yes.
So we do a lot of work on this Subitizing, be able to spot this in relation to 5.
And is this whole class, or does this have to be kind of small group?
You can do it in small groups. You can do flashcards, activities with very young children. We don't want the formal teaching, the bold beginnings, but that's another story. But you can do it with small groups. You can do it with whole class activities. And then we're also trying to do that outdoors as well with big equipment and just make it part of natural play as well.
And we're not talking, this isn't to try and get the concepts of addition or subtraction or anything.
No, that's the whole thing. That they move children on too quickly to doing operations, which is adding and subtracting. And before that, there's a whole world of number sense to be built up first for that to make a lot more sense.
Okay. Well, yeah, tell me more.
So one of the things that we use is the 5 frame and 10 frame.
Okay.
So one of the important concepts also is about one more and one less.
Okay.
And we'll come to that in the negatives as well.
Right,
because we don't do enough on that, I don't think. So there's 0, and one more is 1.
Okay.
And one more is 2.
Yeah.
And one more is 3. And one more is 4. And one more is 5.
Okay.
And one less is 4.
Yeah.
And one less is 3. And one less is 2. And what we're trying to do is to build up a mental, not a number line, but a number track.
Oh, okay.
So children need to have stored in their long-term memory a visualization of when you say 1, 2, 3, 4, 5, you know that the number 1 less than 5 is 4. You know that the number 1 more than 3 is 4. And they need this sort of to know where numbers are in relation to other numbers.
Now, what you were very careful there to say not a number line, a number track. Now, I'm starting to get a bit obsessed with these number lines at the moment.
Brings in picture of number track.
And what's so for the benefit of people listening here, what's the difference between a number track and a number line, and why is it an important difference?
Somebody wrote an article, but I can't remember the name of it recently. He went to China and said, I've just realized that we're pushing the number line. Actually, there's these Chinese kids doing exactly the same concept, but using counters and the cardinal aspect rather than the number line, which is ordinal. So when you're dealing with young children, you're doing the cardinal aspect, you're counting things. So on here, we've got 1 counter, on 2, we've got 2, on 3, we've got 3. So this is a number track here.
Yeah.
And when you always have these in the playground as well. So when a child steps off number 1, he lands on number 2. That's the only place he's going to.
Got it. So
I'll come back to the number line in a minute. So if he's on 2 and he jumps onto 3, he's straight onto 3.
Got it. So this is almost like a board game or something, right? With the squares.
You know, we play lots of games with children. They roll dice and do things.
Got it. And crucially, these numbers, and again, just to be really specific about this, they're not at kind of intervals on a number line. These are like that square represents 1, and the next square is 2, and it's about the movement, is it? Kind of
we get the children to do physically, so they will actually move, or they'll move on a board.
Got it. Okay, so we've got the track on the top, we've got the words for the numbers below.
They can be, the representations can be dots, they can be Numicon pieces, they can be Cuisenaire pieces, they can be tallies, they can do pictures of hands.
Jeez.
We use hands as well. So the idea is you have perceptual variation. You have lots of different ways of looking at this concept of building this model of a number line eventually, but a number track for the moment, about where numbers are in relation to each other, particularly 5 and 10.
And why are they?
Because that's how our hands are built.
You've got the thing right.
So you have 1, so this is counting but modelling. So 1, 2, 3, 4, 5.
Yes.
4, 3, 2, 1. Different countries do it different ways, by the way. But so when we ask them to show 4, we want them to just do that.
Okay.
So why? Because that's 1 less than 5. Show me 2, I know that that's 2. Show me 0, so we do that.
Yes.
So that they need to know the numbers, all different representations. Whereas when I was at school, so here's the number 4. Spell it, F-O-U-R. Show me 4. Good, we've done the number 4. And you move on. And that's just not deep enough. It's not enough different variation in the way you're looking at it.
Got it. Gee, and again, whenever you were doing the counters and you were going 1 more, 1 more, is that kind of whole class almost kind of chanting? Is it like a shout? Okay, I like it.
And it's not the number after or before, because that's more abstract.
Oh, it's
an actual physical activity. You're actually leading, when you're doing 1 more and 1 less, you're beginning to lead towards addition and subtraction.
Yes.
But you're using the phrase 1 more. Children, because they get language from somewhere else, might say, I need to add 1 more, or I'll take 1 away. But we'll be saying 1 more, 1 less the whole time.
With the 1 more.
Yeah.
And again, there'll be some stupid questions coming from me left, right, and centre here, Bernie. But like, because because I've never taught, certainly never taught, I've dabbled in a bit of year 5 and year 6, but never kind of early years, never year 1 and 2. So I don't know how to pitch this. I don't know what kids know and what they don't know. So you never, from here, you're not going to chuck in a 2 more, are you? Like, would you
actually,
go near
2
that,
more
or?
is really, ideally you would, but it's apparently not. I think I'm not very good at memorising, as you know, but I think we're talking about that's a target for maybe 6-year-olds.
Right, okay.
Whereas 1 more is definitely something you want everybody to get their heads around. 2 more is an aspiration, but a lot more difficult.
Okay. Okay, and again, just to return to the number line, because if this,
the number line.
Yeah,
yes.
if I was put, I mean, God forbid this never happens. If somebody said to me, right, you are going into an early years class and you've got to teach concept of 1 more, I'm banging out a number line, I'm getting the jumps going, and I'm thinking I'm doing a good job. But what's the issue with the number line?
Okay, so the number line came very late in mathematics. And it's certainly not primary, it's very difficult.
Right.
So when you say 1, what you're doing is you're measuring the distance from 0.
So the concept of 1 is a distance of 1 from the 0 to 1. That's interesting, yes.
And the number 2 is a movement. That's what we call directed numbers. We do the positive, negative. It's a movement of 2 that way. So if you're at number 1, where are you anyway? It's this dot that doesn't actually exist in maths. And then you step off number 1, where are you? Into this scary big space here with an infinity of numbers in it.
Yes.
And that's way too abstract for young children. Whereas here, you step off number 2, where are you? Oh, I'm at 1 more counter, I'm at number 3.
Right.
So this is cardinal about counting objects. And that's children find that much easier to do. This should come much later.
When should it come in the number line?
In Singapore, it doesn't appear until year 3.
Right, okay. So that's age...
That's actually the same age as our year 4 children, because they, like everyone else apart from us, they start school a year later.
Right, okay.
Because they've read the research.
So what's that? So that's kind of 7-year-olds, something, 7, 8
Yeah.
So no number line before then.
Yeah.
That's it. That's fascinating.
Well, why did we invent the number line? Because it would be beyond integers or counting numbers. We needed fractions, decimals and things.
Yes.
Well, these children aren't dealing with that.
No.
Well, they are in our country because I think the early years curriculum asks them to do halving and doubling, but that's another story.
Right, okay. So we're dealing with it, and we're focusing on getting this number sense, 1 more, 1 less, understanding the different representations for each of the numbers.
Yeah.
What do we do anything else with this?
Oh, yes. Yeah, they've also got, I said that one of the problems with all of these equipment is that you're still counting in ones.
Yes.
And we were out in Uganda recently, and we had a load of these rekenreks.
Oh God, I was hoping this wasn't coming into play. So this is the thing that I'm pulling an abacus.
I'm going to put this over here. So we start with the red on the right.
Okay.
Apart from Uganda, where they were made the wrong way round, but that's another story.
Okay.
So when children are starting here, you'll notice there's still about this 5 and 10. This idea with hands, 5 and 10. So everything is 5 and 10.
So again, for the benefit of people listening, and I'd strongly recommend you check out the video for this, but if you're in your car, you've got here 5 white counters and 5 red counters.
On the top rack.
On the top rack, and 5 white and 5 red on the bottom rack.
Yeah.
And they're all to the right of this rack.
Yeah, so that's the start position. So if I want to show the number 1, I'm counting in ones. 1, 2, 3, 4.
So you're sliding them
5,
across from right to left. Okay, I'm happy so far.
We want them to recognise that that's 5 because, not counting them in ones, but because all the white ones are over there. We want them to recognise this is 5, not because they're counting, but by recognising that the 1 row is full. So that's called subitizing, where you recognise just by looking.
Now this is interesting, Bernie, because again, I'm going to come across terrible at this, but I might as well get it all out there. Whenever I'm asked to teach kind of bottom set year 7, I have a flipping nightmare because I'm very much aware that kids need to know their multiplication tables. Yeah. But what I want them to be able to recognise and know that 3 lots of 5 are 15 and so on. But what I see is kids just kind of counting up to 15. And they're like, well, but I can get the right answer. And I'm like, yeah, but how much strain is this taking and all this kind of thing. So how do you stop them just counting those 5, Bernie? How is it just constant repetition?
This is what I love about this, because what you find with the 5 and 10 frames is that when children are making these, there is a likelihood they're still counting actually in ones.
Yes.
And you are putting them down in ones. So this was a revelation for me about 12 months ago, so that you know this is 5. So when we start doing with the children, we start saying, okay, show me 5. And we don't want them to do that. So what we want them to do is go straight to the fifth one and do this.
Right.
So they're seeing that as 5. They're not counting in ones.
Got it.
And that's going to make a massive difference to these kids. So then we go, okay, so what's 1? What's 1 more than 1? 2. What's 1 more than 3? 2, 3. And you get to here, what's 1 more than 5? That's 6.
Yes.
Okay, so let's move that back. Can you show me 6 in one slide?
Straight off, right. And they're relating it to the 5 all the time.
And also, they've got this. They've got their fingers. They've got the 5 and the 1 more. So they're beginning to now work towards 10. So you've mastered 5.
Yeah.
So now you've got 5 and 1 more, 5 and 2 more, 5 and 3 more. And you carry on through this. What's 1 more than 6? 7. What's 1 more than 8? What's more than 8? 9.
Yes.
And you're pointing out that if you see 1 left over here, this must be 9.
Right.
Or if you see it's 5 and it's 4 more.
Yes, okay.
And the other thing you'll be, as well as learning that, you're starting to learn your number bonds. So over here, if we go back to the 5 frame,
yes,
you can have all 5 and none yellow, or you can have 4 red and 1 yellow, so 4 and 1 makes 5.
So these counters, Bernie, I've noticed they've got a red side and a yellow side, and I'm guessing that's going to be important.
Yeah, they're called double-sided counters, and they're one of the best things I've ever found for doing loads of, particularly with young children. Yeah.
Okay, so talk me through it. We've got 5 reds showing here.
Yeah, so we've got a 5 frame here, it's full, so we know that's 5 without counting.
Yeah.
So we've got 5 red and we've got none are yellow.
Okay.
So we know that 5 and none is a pair that makes 5, if you like.
And not 5 add none, 5
No, we're saying and, yeah, good. So
Got
this is pre-arithmetic, before you do arithmetic. And then if you do all this, arithmetic comes a lot quicker.
Okay.
So if you turn 1 over, you've now got 4 red and 1 yellow.
Yes.
So you know that 4 and 1.
Yes.
Those are the 2 numbers,
Yes.
the 2 parts that make the whole.
Yes.
These are part-whole concepts. That number 5 is also made up of 4 and 1.
4 and 1.
I'll just mention this is all called hierarchical inclusion here. I told you early years maths is difficult.
God, I'm at my head.
Later on, if you want to do 5 take 4, children have to realise that 5 has got 4 in it, so you can do it. So that when you get to 5, 4 is in there. So when you see 5 here, it's also got 4 in there as well as 1.
Right.
So when you try and do 4 take 6 later on, you have to realise that 6 isn't hierarchically included in 4, so you can't do that when you're younger.
Right. Well, this potentially could open a whole can of worms here. So I'm going to ask my hard question first, and
I may answer it later. But go on.
Come back to this. So, because this is one of the things that kind of concerns me. I think it's probably the right word. So, if you say you've got a kid in there who says, "All right, I want to do 4 take 6."
Yeah.
What do you say? Do you say you can't, or do you say you can't yet, or what's your answer? Because with this,
Depends what age he is.
okay, well let's say it's it happens within this lesson.
Yeah.
So we've got a young kid, 4 or 5 or whatever. We're playing around with these things because I would struggle to see how this would get me the 4 take 6. So what do you say? Is it a can't? Is it a can't yet, or is it?
Yeah, I mean, I think that going into negatives comes a lot later, and also I'm not at the stage where we're doing addition and subtraction yet.
Sure, of course.
But if you had 6 take away 4, and there are actually 2 concepts of subtraction, but we haven't got time to go into that today.
Yeah, sure.
So if you take away 4, 1, 2, 3, 4, you can actually do it. But if you had 4 take away 6, there isn't 6 included in this. So at this stage, well, we're coming to that later.
Sure, of course.
It is not possible to take 6 away from there because 4 does not contain 6.
And do you kind of do it as almost like a teaser for them? Do you say, because I think there's a danger. If you say, you have a lot of kids who say you can't, right? You can't do 4 take 6, this comes into a lot of areas of maths where it's not that it can't be done; they just haven't seen how to do it yet. So I'm just before we obviously we'll dig into the negative stuff later on. But what is your response to if a child says, "What's 4 take 6?" and you're not at the stage yet where you've not introduced negative numbers, blah blah blah. Just what's your answer?
With a young child, I personally probably just say, you know what, we'll have a look at that one when you're older.
Right.
I'll teach you that later.
Yeah.
Otherwise, you're going to open a can of worms for all the other
course.
children. But the other way you can do that is you can put 6 counters. There's a lot of work with young children on hiding things.
Yes.
So you put the 6 counters in a bag, and they have to say whether you're telling the truth or not, whether it's possible. So you're going to reach in and go, I've pulled out 2 counters here. Do you think that's possible?
Right, okay.
Yeah.
Yeah.
So suppose you've got 4 counters in there, And you say, okay, I've got 4 counters here. I put them in the bag. Okay, I'm going to reach in, and I've taken out 1 counter. Do you think that's possible? Yeah, good,
nice.
good. Okay, I've taken out 4 counters. Do you think that's possible? Yeah, good. I've taken out 6 counters. Do you think that's possible? No. Why not? Because you only have 4 in there, and you can't have 6 in there. So there's a lot of hidden practical ideas like that as well.
Got it. Okay. And my other question, which may be a stupid question, is, so we've kind of done quite a few concepts here with the rekenrek. I'm saying that right? And the different representations of numbers. Now we've spoke a lot on the podcast about how the lesson is probably not the best unit of time to think about for planning.
No.
What's going on here? Are you picking kind of one concept to do per lesson, or is it like you're doing with me, where you'll do a bit of this, then we'll do a bit of counting? Now, is it more the latter?
It's really difficult with these young children, because you've got these, Sarama and Clemens talk about learning trajectories. So you have learning trajectories for each particular thing you're doing. It's so complicated. Our scheme took ages to put together. And it isn't neat, so you've got lots of different things firing off, so you're trying to keep everybody on about the same place if you can, but you'll be hitting different elements of these learning trajectories at the same time. So you try and design play and activities to integrate all of these things. And you need to be, whatever concept you're working on, you decide what you're doing with that, but you need to be representing in lots of ways, including lots of play, games, getting outdoors, physically doing it. It's really complex.
Bernie, and we're only just getting warmed up here. and my other potentially daft question is, what does the practice look like of this? So say you're doing this in say 20 kids or even 25 kids or more potentially. I can imagine you kind of demonstrating this at the front, but do the kids do any kind of practice on their own? And if so, what does that look like?
Yeah, practically they play games with each other. So they'll, with Subitizing, you'll have Subitizing cards. So they just let them play games. They have to do a lot of play. So they'll maybe hold up a card to their friend, and their friend has to say, just Subitize very quickly what was on there. And the answer's on the back, so the other kid knows what's on there. Okay. So they play games with each other, and they probably move a counter on a board, so they've got some target as well. So it's about them playing with each other and playing games. The TAs knowing how to get involved with that, what questions to ask, how to move children on with their thinking. So it is very complex for TAs as well. So a lot of games, a lot of working together in groups, a lot of play.
Got it.
But what I think it's Cameron calls guided object play. So children are working with objects. It is play, but the adult knows what it is they want to get out of that play, and where exactly where they're going with it, what they can ask, what they can do, how they can move children on.
Got it. And I mean, I spotted these things at the start.
Thank you.
Numicon. Now, I'll be honest with you. So we've done some work on diagnostic questions with White Rose Maths, and they've written some diagnostic questions for years 1 through to year 8. And in some of the year 1 and year 2 questions, I see these things on the images, and I don't have a flipping clue what's going on with them, because I can see. So we've got like something I assume represents 1, which is a square with a circle in the centre. 2 I get. Again, we've got kind of on top of each other or to the side of each other. But then 3 is like an L shape. And I don't, so I'm fascinated by this. If I was designing these, like 3 would be again like a 3 on top of each other. Well, tell me what's going on.
The interesting thing is that we're in OUP today, and out of all the people in OUP you'd asked about Numicon, I'm probably the person least qualified to answer that. However, my understanding of this is that it's basically, whereas these things go in a line, you look at linear, 1, 2, 3, 4, 5, 6, 7, 10, 1, 2, 3, 4, 7, 9, 10, that's the 5 frame and theirs. These go 1, 2, 3, 4, 5, 6, 7, 8, 9,
so
10.
For the benefit of anyone who's still listening, and as I say, I would strongly recommend you watch the video here, but you're counting not up.
Yeah.
You're kind of 1 to the left, 1 to the right, then the next kind of level up to the left, to the right, third story, left to the right. And
so you're going basically 1, 2.
Oh, and you're kind of replacing.
And then 3.
I see.
And then 4, and going up that way.
That makes perfect sense. Okay.
Now, for me personally, and a lot of the guys I work with will disagree with this, but personally for me, the real strength of this at the beginning is about the part-whole idea. So that 3 is also made up of 2 and 1.
Got it. So you've got the L-shaped 3, and you can show by placing the 2 and the 1 on top of it and covering the whole thing.
Yep.
That 3's made up of 2 and 1. That's nice.
And the nice thing about that is that this isn't 2 1s, it's a unitized 2. So this isn't 2 separate 1s. This is a block of 2 called unitized. Whereas with this, I could show you 3 with the double-sided counters and turn it over to show it's also made up of 2 and 1.
Yes, yes.
So we've got different representations here. But one of the key things that children for number sense is to know that if you've got 5, that could be 5 and 0, 4 and 1, 3 and 2, 2 and 3, 1. They need to know that. They need to have that in long-term memory.
Jeez. And is the key to chuck as many different representations at them as possible? Is that the key? And there's no risk of kind of bombarding them. And the reason I say this is because, and again, just relating it to my secondary knowledge, sometimes kids say to me, just give me one method that works, please. So if it's trigonometry or something, I'm just going to do it using SOHCAHTOA. I'm just going to use the formula. I just want one method that works for me. And whereas I can see the benefits of multiple methods, but I can also see the dangers that kids can get confused and so on. But is that different? Here is it win-win, giving them as many.
Because this isn't a procedure. It's not a method. It's a concept.
Yes, okay.
And in order to get a concept, you need to handle it in different ways. So my favourite example is you say to children, okay, this is a chair, Craig. It's a chair because it's got 4 legs.
Okay.
Okay. And then a dog walks past the window and the child goes, oh, look, it's a chair, it's got 4 legs.
Right, okay.
So you need to have, if you just teach by definition and then one example, you're probably building in a myriad of misconceptions that we were talking about last night. And it's getting the very beginning right, that the concepts are clear, so they really understand what 4 is, not just writing 4 and spanning 4 and 4 dots. But that's 4, that's 4, that's 4. 4's made up of 3 and 1. Oh, 4 is 1 before 5, or it's 1 after 3. Then you really have a sense of number.
Now that's interesting. Now let me ask as well, whilst we're talking examples, I'm obsessed with non-examples as well. And it kind of goes back to what you're saying there, that unless kids see examples of things that work and don't work, they can get a very limited idea and misconceptions can come. So would you, within this kind of sequence of activities, would you chuck in non-examples?
Oh,
So what would be something?
Oh, nursery. So they have the puppet.
All right, okay.
When I teach older children, so I say I have a friend who does this. So they may be putting up something like this on the board, and so they'll have a puppet on their hand and say, oh, what's that one, Mr. Puppet? Yeah. Oh, Mr. Puppet says that's 4. What do you think, children?
Oh, okay, right,
So you can't make the child feel embarrassed, but you can have this puppet here that makes all the mistakes. That's the non-examples. And then the children have to explain why the puppet's wrong, how they know that's 3, and in lots of different ways. I know that's 3 because I can count them. I know that's 3 because I can subitize 3, and our nursery children use the word subitize.
You're joking.
No.
Subitize.
Yeah. And or they say if there were 2 more, there would be 5. So they not only have to use non-examples, they have to explain and justify why that's 3.
Flipping heck.
And that's what you spend all your time doing at the beginning, not rushing on to adding and subtracting and writing.
Give me a sense of how long this is taking, Bernie. So are we talking a week, a month? Or is this the entire year?
This is a 2-year program.
2 years. And they're not doing, are there other mathematical concepts mixed in?
There's lots of shape and space.
Right. And you just keep coming back to this, right? It's not done in like a 6-week block.
No.
It's just constant.
Constant immersion everywhere they go outside in the playground. There are 5 frames, 10 frames. We want to build a huge rekenrek out of them to play with, so they're having conversations. And every adult needs to know that they can join in those conversations and how to help build children what they're doing.
Got it. And does it, like in, again, and apologies, I keep referring back to secondary here, but so the way that I would try and interleave fractions and decimals would be to like include it in area and perimeter. That's always the classic thing. Is it a similar thing? Does this explicitly come into the shape and space stuff that kids do? Is it just
I didn't bring them today because I didn't think this would turn up, but there's things called pattern tiles.
Oh, right, okay.
Which were, like a lot of maths, it was great in the 60s and 70s, but seemed to fade away with national curricula, etc. Another story. But the pattern tiles are amazing. They're part wholes as well, and we've been investigating those with our nursery, and they've been putting, I wish I could show you, this on my Twitter site, they're putting together phenomenal bits that form together, but there's still the whole idea. All geometry, you know, you're talking about in your book about where you have geometry pictures and they have to maybe decide that there are two triangles in there and break that apart. That starts right down the beginning. So all this whole idea, concept, not only applies to numbers, it applies to geometry. So they're getting so they'll take that concept into other areas as well.
Got it. And this will become a recurring theme in this interview, but I wonder if it's worth commenting now. Is there a need, and if so, when, to move kids away from these representations? Or is that not a big issue? Does it just happen?
Concreteness fading. Right. So eventually, our target is that by the time the children come out of reception, because we run the Singapore Maths program in year 1, they've got to be really happy with all of this, but they have to have taken away the mental models and they have to have taken away the number facts. That's going on in a new trial version of the early learning goals at the moment in this country in several schools, a couple of schools, a number of schools, and they've reduced it down to really focusing on this stuff. But we believe that children can come out of reception knowing their number bonds, their friends that make 5, knowing their number bonds that make 10, and then that's essential for the Singapore program that we run.
Got it.
So they are going to, we still keep using these in year 1 and 2 and further up, and we use these representations up in column addition and subtraction in year 4, but they need to have that stored in long-term memory because they're going to use this for addition, the way they teach addition and subtraction, which we haven't got time for today.
Jeez, got it. Okay.
It's so well thought out. It comes from Singapore, basically, who researched the whole world. It isn't Singapore as such. A lot of it came from Britain, but we weren't doing it.
Jeez. Well, is there anything else on this particular thing that we haven't covered yet?
One thing I did mention about hidden things.
Oh yeah.
So when you're trying to get children to learn, so we've got the rekenrek here, so I'll put it over there.
Okay.
So you might say to children, close your eyes, close your eyes, close your eyes, close your eyes.
Oh, am I doing this?
Yeah.
Oh
close
yeah.
Your eyes, close your eyes, close your eyes.
Go on. Yep.
Do a lot of this hidden stuff. Okay, open your eyes.
Okay.
Okay, how many red ones are hiding on this side on the top rack?
2 I'm going for there.
Right, and how do you know that?
Because there's 3 on the left.
Yeah. So you know there's 2 missing there.
Yeah.
Or there's 5 and 3 is 8, and there's 2 more.
Yeah.
So although we want children to learn these facts out by heart, we do them in a game-type situation, a play situation.
Yes.
And they can play that with their partner. They can do hiding things. They can first of all start with 5. They can do it on here as well. So hiding things is a really great way of making children do things. I haven't got time for the whole thing today, but there are a wonderful book on, is it Making Numbers? I think it is, published by UP as it happens.
Nice.
And you have Learning 5 Friends. So you have, these are animals in the one. So there are 5 animals.
Okay, so we've got 5 counters here.
5 counters there. Okay, close your eyes, Craig.
Okay,
closed. Thank you, Craig. Well done. Okay, now, 2 of the animals, you can open your eyes now.
Okay.
Some of the animals have gone to bed.
Oh.
How many animals do you think there are there?
I think 2 animals have gone to bed.
And what's interesting is when you hide things, children will count things they can't see. So they'll go 1, 2, 3, 4, 5.
Okay.
And this is how you get them to start counting on without teaching it formally. They will start to do it. So hiding things makes a lot of things happen, provided the adult knows how they can help make those things happen.
Jeez. And I'll tell you what, final question before we move on to our second thing.
Yeah.
You mentioned before that when you were in Uganda, you did the example of 9 plus 8, and you had the kid who saw 9 as just a series of 9 ones, and 8 as a series of 8 ones, and then when they were adding them together, essentially just counted up and got to 17 ones. So and what age was that? What age are we talking about?
They were equivalent to our year 4.
Year 4. So what do you do there? Like, can you unpick that? Do you have to go back to this kind of stuff with those kids?
Yeah. So what we're doing, in order to improve the maths at secondary, we've focused on just the early years. So they have a baby class, middle and top, which are equivalent to our nursery reception year 1. And we're trying to change the teaching there to give them develop this number sense. So when they come up to there, all they'll do with this is they'll shift one of those over there. And say it's 10 and 7, 17.
And with that child, that individual child who's doing this now at this stage, what do you do to help them? Like, do you have to go back to this stuff?
Yeah. So
there's
we're saying,
no shortcut to it.
Yeah, start your lesson. I mean, I worked with a girl outside who was year 6, very bright, but dyslexic like me. And I said to the parent, the only way we're going to, I was privately tutoring her, so the only way we're going to do this really is to go back to nursery.
Right.
Do you trust me to do that? And we did. So we went all the way back to using 5 frames, 10 frames, build up number sense. 6 months later, she got moved up a set. And after that, she got moved up 2 sets, and then she was in the top set.
Flipping
But there was no choice but to go back and build that number sense that she didn't have.
And if you...
So you can start every lesson with 10 minutes of this.
God, and if we've got secondary school teachers listening who have kids in year 7 who don't have this number sense, is that the advice there? That you have to go,
with any
stuff?
teacher, this is why I love it, why I bought into the Singapore approach, concrete, pictorial, like we're doing dashes here, and then abstract. If they're ever in doubt, if a teacher comes to me, go back to concrete.
Yeah, okay.
Go back to concrete. It's not going to stay on concrete, but you have to go back there. Whether it's learning tables, I've done that with big rekenrek frames as well. Go back to concrete, develop the concept, develop the skills, and then they will abstract that.
Got it. Got it.
And they'll also learn it a lot quicker as well.
Right, you've sold me on this one.
Okay.
I don't think I'll be able to do a lesson, but I'm with it so far. Okay,